hundreds of kilometers from land, buried beneath the Earth's surface, an untapped energy source that could help reduce carbon emissions. Natural gas. But these fields were too remote to be accessed. Until now.
It's going to be a city of its own.
A game-changing vessel is being built unlike any other.
This module is about 2,025 metric tons.
It extracts, liquefies, and stores natural gas in far-flung offshore locations. And in the future, could eliminate the need for undersea gas pipelines. Its 132,000 tons of steel will be capable of pumping gas from 200 meters below the ocean. National Geographic reveals the world's first floating natural gas facility. Around 180 kilometers off the shores of Sarawak, Malaysia, lie the Kumang Kanawit gas reserves. Trapped in rock beds almost 100 meters deep. Remote gas fields like these make up nearly a third of the world's gas reserves. Till today, they remain hard to reach using conventional methods. But that's about to change. Petronas is building a massive floating facility that stands 10 stories high, a game changer on how this precious resource is mined.
Petronas has been looking in trying to monetize small and stranded gases for a while, since 2006. It's a very bold and courageous move that is made. There are no references and no benchmark.
Global Fortune 500 company Petronas is Malaysia's state-owned oil and gas company. They have to address a huge challenge that the industry faces. Volatile and highly flammable gas. To make natural gas safer to work with, massive processing plants on land will first cool it to a negative 162 degrees Celsius, where it turns to LNG, liquid natural gas. LNG takes up 600 times less space, making it easy to store and transport large volumes. But it's never been done at sea.
One of the major challenges is basically we will be operating equipment that are as big as compared to the onshore plant.
And this is the mega factory that will achieve the impossible. It's called the PFLNG Satu. For the last year, this has been her home. An extensive deep-sea port on Goje Island, South Korea. And in 14 months, this mega vessel needs to be ready to sail. This 365-meter-long gas processing plant took 10 years to conceptualize and design. The first problem, how to store dangerous liquid gas at sea and keep it cool in the tropical heat. The solution, to design colossal tanks within the giant hull. It will be the first in the world. But it needs to do more than just store the gas.
For this FLNG project, the hull that we designed is basically to support the topside module to be operated for 20 years with good fatigue condition.
This hull has to withstand over 48,000 tons of steel that will make up the processing plant. Once the hull is finished, the construction team needs to build the tanks that will store the liquid natural gas.
Okay, because the tank is very big, okay, about 27-meter high. This is basically the best time to enter the tank. So this tank gonna be a dangerous tank because we will store LNG at minus 163 degrees Celsius. So nobody can enter the tank.
The cavernous interior can hold nearly 22,000 cubic meters of liquid, the volume of almost 9 Olympic-sized swimming pools. It takes 20 shipments of gas to power almost 700,000 households across megacity Tokyo for a whole year. Putting the tanks in the hull is an innovative solution when it comes to saving space. But there's a danger, especially when it's partially filled. The vessel's movement could create an immense unstable sloshing of the liquid.
The sloshing effect is basically if you have a cup or a pail, right? You fill it with water, right? And you start rocking the pail, you can see the water sloshing back and forth.
With enough force, the 1 millimeter thin membrane separating the LNG from the hull could break. If that first layer in the tank is damaged, the liquid could escape and embrittle any structure it touches. For lead hull engineer Fahmi Mahmood, this is a nightmare scenario that must be avoided.
If LNG come contact in the hull, it's very big disaster. First, the hull can collapse, and the structure also will follow.
A gas leak could lead to an explosion, and if that happens at sea, it could turn into a catastrophe. How the gas will be contained on board is crucial. To prevent masses of liquid gas from sloshing, the team came up with a unique new design. 2 parallel rows with 4 tanks in each will help minimize the risk of destabilizing the vessel. It is the first operational hull design of its kind in the world. After months of construction, the tanks are finally complete. Now it's time to build a processing plant on top of the hull. To do that, 21 massive prefabricated modules need to be moved onto the ship and assembled. The last one to arrive is a 2,000-ton mega block that will purify the gas.
This is our last module to be transported from the pre-erection area to the key site, where the final location before we lift up onto the floaters.
Maneuvering these mega blocks requires a heavy hauler with 112 axles. Even the slightest jolt during the move could damage the cargo above.
We need to move slowly because we need to make sure that the ground conditions are synchronized and automatically level to avoid any movement to the modules. Okay, Alhamdulillah, our module already arrived. No major issue during the transportation. Now we are waiting for the transporter to setting down. And then after that, we already schedule our lifting.
To lift these towering blocks onto the vessel, a 3,600-ton floating crane is needed. But the ship needs to turn around to receive the next batch of modules. Easier said than done.
It's like a puzzle. We need to plan early the sequence of erection on a module so we can limit our hull turning.
Turning the hull is going to be a huge operation for the team. The ship is yet to be balanced out properly, and turning the vessel leaves everyone on edge. At a height of 10 stories, strong wind could see the vessel on balance. A potential disaster.
작업장 이동하시는 속도를 갖다가 좀 확인하셔가지고 좀 급하지 않게 천천히 좀 작업해달라는 당부가 있었습니다.
Fahmi Mahmood and the team is gearing up for the turn, and the clock is ticking fast.
We have the target to complete the hull turning activity before 10 a.m. Because start from 10 a.m., the wind speed start picking up to 15 meters per second.
In order to turn the platform, all neighboring vessels have to keep a minimum distance of 100 meters. Making sure that the conditions are right is causing worry to the safety officer.
This looks like parking a car, right? But in reality, the whole condition is different. It's a sea. The risk factor is really high. One mistake, everything can go wrong. So you got to get it right at first time.
A massive black vessel is too close for comfort. There's no telling how long it will take to be moved away. And time is running out.
Control the approaching speed.
So the wind has picked up now.
Yes.
So what was ideal wind speed we expect? 5 knots?
Just now it's 5 knots. Now we expect around 7.
The team has to start soon or endanger the vessel. Construction on the world's first floating natural gas processing facility is almost done. The next step is to lift the remainder of the 21 processing blocks onto her hull. One side of the vessel is fully loaded. Now she has to turn around to receive the remaining blocks.
We have a concern about the distance between this FLNG with another mega block.
After a few hours, the vessel causing the holdup is finally towed away. And the vessel can now turn without obstruction.
So right now 3 ducts are... That's one of 3 ducts are...
That's one of the things.
With the vessel's current weight of 112,000 tons, 4 tugboats gently move her at 1 nautical mile per hour. Turning the vessel on the first try is a success.
So thank everybody for the great effort, for the good coordination. Thank you very much.
Now she is ready to receive the last 3 components onto her hull. Project engineer Nick Seifel oversees and ensures that everything runs according to plan.
Okay, we come to the last 3 heavy lifting for this project. At the moment, there it is, the module. We're going to leave it over there. And then the second heavy lifting, which is the flat tower, will be erected here. And then the last module will come in between the module and the flat tower.
In order to lift all 3 components within 1 week, the operation has to run perfectly to time.
So many items.
Also, items to check with the
So make sure the vessel for flare move out 1 o'clock. Sharp.
To load the gigantic module onto the hull, the work crew first has to attach it to the crane with giant shackles.
This module is about 2,025 metric ton. And 1 shackle weight is about 900 metric ton.
It's a lot of weight to be balanced on a floating crane. And construction engineer Asnan Saman is nervous.
Now we are worried about the clash point because so many scaffold underneath. So we also afraid that when the excessive movement, it will break some of the outfittings underneath of this module.
With almost 6,000 tons hanging off the floating crane, the atmosphere is tense. Wind and movement could cause the module to swing and damage its underside. It would take months to repair and a huge delay to the construction schedule.
Okay. Alhamdulillah, it's no problem. It's a big achievement. Okay. Now our module already completely lifted up. It's away from the support stool. Now they will detach the mooring line, then the floating crane will move up from this area. Now sits down.
The first stage went smoothly, but the danger is not over yet. It still needs to be placed on the vessel's deck. The work crew is standing by to receive the module. The success of this lift will determine whether the next block can be lifted in on time. But as it reaches the deck, a colossal challenge. It cannot fit onto the hull, and 2,000 tons of steel is suspended in midair.
One case, construction going wrong, another case, fabrication wrong. Anyway, both ways, this is wrong.
Safety first. We cannot too long hold this.
Okay, basically this is our problem now. The top part, we are not slot into the bottom part.
The Petronas team has to think fast. The longer the 2,000-ton module suspends in midair, the higher it risks experiencing bad weather, which may cause the module to swing, damaging the vessel and injuring the crew.
At the moment, we are trying to rectify by cutting the structure and refit it. So once that has been cut and we weld it to the original location, which is about 200 mm apart, yeah?
It seems like a simple welding job, but with huge ramifications.
You don't want the wrong cutting. That's my concern. If you have to be really clear.
No misoperation.
Then they need the one will be create another problem. Make sure that engineer clear. Then the rectification team know what they want to do.
The module has been hanging for 3 hours, and every minute increases the danger.
This is the biggest worry.
The world's first floating liquefied natural gas facility, PFLNG Satu, is well into its final year of construction. The vessel is beginning to take on her final shape. But there's a problem.
I don't want anything happen to the module.
A massive 2,000-ton block cannot fit onto the deck and is hanging as workers race to cut and re-weld new legs. It's a dangerous situation, and the teams work through the night. It is 8:30 a.m. and time to check if the new welds mean the module can fit on the deck.
Okay, done for today.
Asnan can heave a sigh of relief. After overcoming a major hurdle, they are one stage closer to the final phase of construction. Next, they need to connect the modules with a massive network of pipes. Like veins in a body, they are a vital part of the processing plant. It's through these that gas flows through the platform to the storage tanks.
Right now, the piping work is the backbone of the project. Currently, we are at 97% of construction, just another 3% for completion. But anywhere in the project, the last 5% is very difficult.
Pipe spools are pre-assembled lengths of pipe, and each spool has to be inspected, tested for cracks, cleaned, and then installed. If cracks are found, the whole spool will have to be replaced. Sounds simple enough, but the ship has 35,000 separate pipe spools, and it can get pretty hard to keep track of it all.
Okay, have you confirmed the joint is ready? I heard yesterday they're still working on the cleaning process.
It's already done, so they called us to witness the preparation.
The task of keeping track of all 35,000 pipe spools falls under the expertise of engineer Sharifa Farah.
Let's say one piping is not connected, then other system cannot run off. We have 21 modules in this project, so it's not an easy job. You need to be on your foot all the time.
With so many spools to keep track of, it's a huge job, and she's one of the few women in the team.
I think it's interesting because you are dealing with a lot of kind of people, and you need to be firm with your decision. I don't give them a chance to treat me differently. So if this goes up, then it's acceptable. Okay.
She is testing a huge cryogenic pipe. The welds themselves are the weakest part, and if LNG escaped, the warm air could turn it quickly back to natural gas, making it potentially explosive.
We are detecting the cracks on the weld joint, basically. It has heavy wall thickness, 20.6 millimeter. So pout is the best method to test the cracks joint.
POUT, or the phased array ultrasonic test, uses probes to send a pulse into the weld joint. If there is even the slightest crack, the pipes will need re-welding.
So this dotted line is our welding point. So we just monitor if there's any crack detected inside the welding line, right?
Yeah.
Okay.
The welding on the cryogenic pipe passes the inspection.
So it's a pass test. Yeah.
And Farah can move on to another of her 35,000 pipe spools. Now, they are closer than ever to completion. The next step is a crucial series of tests. If the vessel passes them all, she will get its license to be at sea and be commissioned. And the job of ensuring that the vessel functions at sea is Chief Commissioner Khairul Anwar Yunus.
The commissioning basically like handing over a house. Like when you buy a house, okay, the commissioning team will be the last team that will make sure the lights all are in order.
During the commissioning stage, every little detail must be looked into.
Got an alarm, Do we have a leak?
By the time we stop.
The team testing the electrochlorination module has a leak in the pipes. Its function, to clean seawater and make it safe for human use.
Just be careful, huh? Is it possible to tie? Not possible, huh? Okay. Never mind. We keep it like this, so we drain all the water from the drain. Okay? All right.
Back at the control room, operators are monitoring the progress.
Okay. I copy your message, handing over to Kinfai.
But the leak points to a greater problem. If the team is not careful, the water pressure could damage crucial parts of the vessel.
CCR, copy.
We are now slowly draining the tank to address the leak.
Okay, Roger. We will keep on monitoring.
Now what's the plan?
What we're going to do is we're going to get a team with the proper tools. So we're going to arrest that leak.
If the team cannot find out why it's leaking, the sail-off date could be delayed.
We're having leak from the level glass and also from the level transmitter. So we cannot proceed this activity. So we stop all the testing. Better we stop.
PFLNG Satu, the world's first floating natural gas facility, is well into her third year of construction. In 4 months, she is scheduled to sail to her new home, 180 kilometers offshore of Sarawak, Malaysia. The man who will ultimately be in command of this platform is Ikhwan Ishak.
In layman terms, I'm the captain of the floater.
Once it arrives at the final destination, he will be taking control of the platform.
We are looking at before we start opening
But first, he needs to know the ins and outs of everything on board.
If I can show you on the schematics, we should be somewhere in the middle of where the commander is. Okay. Our valve on the platform should be somewhere here.
Okay, that is the red valve, right?
Yeah, the red valve.
This is a crucial part of the facility. Here, natural gas gets turned into liquid gas through a process known as liquefaction.
Well, a liquefaction process, the whole process is essentially like a refrigerator. You have compressors to increase the pressure of the refrigerant. Then you have the refrigerant going through coils behind your refrigerator box.
But to turn gas into LNG safely, Hani Suaib had to design a brand new system.
In onshore plants, we typically use propane and mixed refrigerant, which has to be produced in liquid form. In a cramped space like the floating LNG, the equipment are so compactly built. A single explosion can cause severe damage.
July 1988, oil and gas platform Piper Alpha exploded when liquid gas leaked from faulty pipework. It resulted in large oil fires that eventually triggered further explosions that engulfed Piper Alpha. Within 2 hours, the platform collapsed and 167 men lost their lives. Till today, it still holds the macabre record of the deadliest offshore accident. Today is the arrival of the compander. This crucial part will help turn gas into liquid.
For this particular liquefaction process, without the companders, we don't get the temperature to cool down the natural gas. We don't get the LNG.
The designer of this crucial part has arrived to help install his one-of-a-kind machine.
I was the principal machinery designer on these companders that are used on this ship, which was a very challenging project. So it took approximately 1 year of design work. Wonderful opportunity for me to actually install the product that I've worked on for a long time. 27 and a half.
I got 26 and a half.
Really? Yeah, let me check one more time.
This piece of equipment weighs 4 tons and needs to be installed perfectly in position.
Yeah. We're all, Matt's got to come in. A little bit more. Oh, stop. Okay, 26 and a half. All right, looks good, guys. Let's put 4 nuts on it and tighten them up.
With the critical part of the vessel installed, they are closer than ever to being seaworthy. But the vessel is still not ready to sail. Back at the office, Chief Commissioner Khairul is getting an update from the commissioning team on how the final tests are going.
So when you expect you will start the commissioning?
The first few days for functional check, especially the safety interlock, because we are still waiting for the cooling water. So we will commission the generation first, make sure it's okay.
The team has yet to complete checks on all of the machinery.
Basically, we are behind schedule, so okay, let's support Fauzi to get this one sorted out.
The team has only 2 months before the weather turns too rough for her to set sail. Delays on a megastructure of this size can cost a fortune.
Yeah, I think there is a pressure on me because I'm the one who coordinating with the contractor, with commissioning, with QC, and of course the construction. Bro, how was GG? There's a progress today, right?
Now, it's postponed. Once they receive the material, then they will resume the job.
They will resume later. If I slip the schedule, means the commissioning also have to postpone the work.
She needs to sail on time, and it has to be a team effort.
Oh, so what's happened now?
After a series of delays, the world's first floating liquefied natural gas facility is 30 days away from leaving its docks in South Korea, heading to the open ocean. Its mission is to tap into untouched gas reserves off the coast of Malaysia. There is still much outstanding construction work. The team hopes to complete as much as they can while the vessel is docked. When it's offshore, conditions will be tougher. Project engineer Nick Seifel has hundreds of decisions to make before she can set sail.
Yeah, it looks like it's clashed with the cable tray, we clash with these pipes. We don't have time to repair. Another 30 days from now. Do you think it's possible? We don't have access to bring material. Do we have enough material? Basically, we are counting down. Still a lot of work to do before we sail away. We have this scenario. We want to complete it now. It's a pressure on everybody now.
One vital part the team has left to do, testing the marine loading arms.
Harry is going to start the loading arm now.
Within these giraffe-like extensions are pipes that will transfer LNG gas from the platform to another vessel. This has never been tried at sea before, and it's all in the hands of these remote controls.
LNG is a volatile fluid. If you go to a pump station and you want to fill your car with the diesel or petrol, it's the same here. The only thing is we are transferring LNG, loading LNG onto a ship.
So the operators of the arms need as much practice as possible.
Harry, you have connected the arm now. So see, now still your HPU pump is running. Okay. So what is the next process? You have to stop the pump. Okay, just push and stop the pump. Okay, that's all. So now your arm is already connected.
With one more item off the list, the journey to build this mega floater is about to end. After a decade's worth of dedication and hard work, it's time to take the world's first floating gas platform out to sea. The vessel is preparing to set sail from Malaysia. And the tugmasters have arrived to finalize details.
Plan is for tomorrow, 0700. We will pull all the way out into the basin and then we will turn her around. So, if nothing else, thank you very much. Let's make it happen.
Today, Captain Ikwan embarks on the challenge of a lifetime.
Right. Gentlemen, are we ready for this?
Yes.
So, let's bring it back home and make sure we arrive there safely.
He is about to sail the world's first floating liquefied natural gas facility, a huge maritime achievement.
So now we're going to bring her to the next stage of her life, where she's going to be offshore for 20 years. All PETRONAS personnel, please master on the port side, process that, and give our runner every 5 hours.
Once she unberths, there is no turning back.
It's a big day for us, for the project team, for the operation team as well. So today is a moment of truth. We're going to start our voyage.
The vessel will be connected to 2 tugboats, which will tow her for nearly 2 weeks to her new home at Kumang, Kanawit, 180 kilometers offshore from Sarawak, Malaysia. And once she's there, the stakes are about to get even higher. This one-of-a-kind vessel will be put to the test. After 2 weeks of sailing, the world's first floating liquefied natural gas facility has finally reached her home off the coast of Malaysia. The vessel is safely anchored with the help of offshore engineering partners. Now, the final stage will begin to tap offshore gas reserves from the bottom of the ocean. It will be the first time PFLNG Sat2 will be put in action, and the moment when their vision would become reality. But first, they need to connect to a pipeline 74 meters below.
There is a pipeline already 3-point-something kilometers that goes at seabed. So we will connect at that end of the pipeline and bring the other end over here.
It takes 4 other boats to connect the platform to the gas field. First, divers will work underwater to connect a long hose to a pipeline at the ocean floor. The dive boat, which carries the hose, will move towards the platform. Finally, it will be hauled up to the platform to be connected. But before they can begin, there's a problem. A storm has hit, causing the vessels to be thrown around and work to be halted. With a break in the weather, it's time for the teams to get back to work. Around 74 meters below the ocean, divers are preparing the first half of the pipeline. Working in cold and dark conditions for 8-hour shifts, breathing in a cocktail of helium and oxygen. Offshore diving is one of the world's most dangerous professions.
So as we see, we've got both divers working here. This is diver 2 and diver 1. Roger, number 7 removed. That's number 7 bolt removed. I just give one offshore a shout to get them fired up on the tensioner so we can lower the flexi, you know.
Deck foreman Jimmy Key will lower the next section for the divers to connect them together.
In the next 30 minutes or so, we'll be ready to start lowering down the flexible riser, which we have a pump weight, the big yellow weight right here. It'll pull the weight of the riser down.
The divers are ready. Jimmy unspools the 169-meter-long hose down to the seabed. It's a 24-hour, round-the-clock job for the divers and the team.
Roger, copy that. No, this one. Roger.
The two hoses beneath the surface are now connected. And the completed pipeline is ready to be attached to the vessel. This is the most crucial moment of the whole procedure. The end of the hose is still on the dive boat. To transfer the hose to the vessel, the boat needs to come nearer.
We're going to do our connection with our winch now to the pulling head. When we do the transfer, you're going to see significant load on the edge of the J tube. You keep me posted if it starts hitting sharp edges. Copy?
But with rough sea conditions, the vessels are at risk of hitting each other. They have succeeded. The hose has been hauled up to the vessel.
Transfer went very well. We've got the riser now. That'll be the first production line connected to the PFLNG.
Once the pipeline is tested, she will finally be able to tap the undersea gas fields. From her design to the execution, PFLNG Sat-2 charters waters that no other vessel has done before. She is slated to deliver her first cargo of liquid natural gas in just a matter of weeks. Her journey, which has taken more than a decade, finally comes to fruition as she moors in the waters off the shores of Sarawak, Malaysia. PFLNG Sat-2 shines as an accomplishment that has truly transformed the world of natural gas extraction.